Hello, let's start solving a series given s equal to 1 square into 1 minus 1 by 2 cube plus 2 square into 1 by 2 cube minus 1 by 3 cube plus and so on, right? So let's start solving. Here s can be written as 1 square into 1 by 1 cube minus 1 by 2 cube plus 2 square into 1 by 2 cube minus 1 by 3 cube and plus so on, right? So let's write it in the form of a summation, right? Here it's the first term. Let's consider the first term. Here it is the first term. It is 1 into something, right? So we'll start from n equal to 1, n into 1 by n cube minus 1 by n plus 1 whole cube, right? Then this is adding summation n equal to 1 to infinity, right? So let's simplify this. Summation n equal to 1 to infinity into n into, this will be n into n plus 1, n cube into n plus 1 whole cube, n plus 1 whole cube minus n cube. Fine. Then s is summation n equal to 1 to infinity n cube into n plus 1 whole cube, right? This is by n into, sorry, this is n square, right? As you can see, the first time, sir, this is n squares. This is n squares. This will get cancelled and you are left with n. So let's write it down again here. Then you are left with summation n equal to 1 to infinity, right? Denominator is n into n plus 1 whole cube, n into n plus 1 whole cube. This is a cube minus b cube form, which is a minus b into a square plus ab plus b square. A minus b is n plus 1 minus 1 a square, which is n plus 1 whole square plus ab n into n plus 1 plus b square, which is n square. Fine. Now this n will get cancelled, so s will become summation n equal to 1 to infinity n square n plus 1 whole square by n into n plus 1 whole cube plus summation n equal to 1 to infinity. The second term is n into n plus 1 by n into n plus 1 whole cube plus third term is summation n equal to 1 to infinity n square by n into n plus 1 whole cube. Fine. Now s equal to n plus 1 whole square will get cancelled and you are left with summation n equal to 1 to infinity 1 by n into n plus 1. Fine. In the second term, this n will get cancelled and one of the n plus 1 will get cancelled and you get a square term. Then summation n equal to 1 to infinity 1 by n into, sorry, n get cancelled, right? n plus 1 whole square. Then third term is summation n equal to 1 to infinity n square by n into n plus 1 whole cube. Right? These first two terms I calculated in my previous problem. So let's solve it again. Let's consider this as s1, s2, and this is s3. So s1 is, as you can see, this is a consecutive terms in the denominator n into n plus 1, which can be written as summation n equal to 1 to infinity This can be written as 1 by n minus 1 by n plus 1. Fine. I mean, if you do some math, it will be n plus 1 minus n, and n will get cancelled, and you get 1 in the numerator. Fine. If you start this, if n equal to 1, this will be 1 minus 1 by 2. When n equal to 2, plus 1 by 2 minus 1 by 3. If n equal to 3, this will be 4, and so. So plus 2 minus 2 minus 3 plus 3 minus 1 by 3 minus 1 by 4 plus 1 by 4, this will get cancelled, and you are left with only 1. So S1 is 1. Then S2 is summation n equal to 1 to infinity 1 by n plus 1 whole square, which is, if n equal to 1, this is 1 plus 1 whole square, which is 1 by 2 square plus 1 by 3 square plus 1 by 4 square, and so on. This is a Riemann theta function, right? But there is 1 is missing. So add 1 by 1 square plus subtract 1 by 1 square. This is a Riemann theta function minus 1. Fine. Now let's figure out S3, which is summation n equal to 1 to infinity n square by n into n plus 1 whole cube. Fine. This seems to be somewhat tricky. So let's do one thing here. Let's make, sorry, n square by n into, right? Fine. This n will, one n will get cancelled. Then we are left with n by n plus 1 whole cube. Now let's consider n tends to n minus 1. That means if n old one n equal to 1, then new one will be 1 plus 1, which is 2. So S3 equal to summation n equal to 2 to infinity n tends to n minus 1, right? Then this will be n minus 1 by n tends to n minus 1. Then this will be n minus 1 plus 1. Minus 1 plus 1 will get cancelled. Then this will be n cube. Fine. Then this is summation n equal to 2 to infinity n by n cube minus summation n equal to 2 to infinity 1 by n cube, right? So this will get 1 by n square, right? This is the same as the S2 part, right? Here it's getting started from n equal to 2, right? Then it will be 1 by 2 square plus 1 by 3 square. Then this is the Riemann theta function of 2 minus 1. Fine. This can be written as this. It's a similar one. Riemann theta function of 3 minus 1. Fine. This is Riemann theta function 2 minus 1. Fine. Now S equal to, we need to add everything, right? S1 plus S2 plus S3. S1 is 1 plus Riemann theta function 2 minus 1 plus rho of 2 minus 1 minus rho of 3 plus 1, right? Minus 1 plus 1 will get cancelled. Minus 1 plus 1 will get cancelled. Then S equal to 2 times of Riemann theta function of 2 minus Riemann theta function of 3. So this is the final solution.